Hi guys, this is your video for section 5-6. You should watch this video and take notes in your notebook, and then tomorrow when I'm back we can go through any questions you have about it. Alright, so this section is all about inverse functions. You probably want to have a filled out unit circle in front of you. If you have one in your notebook, go ahead and pause the video and grab that. It's going to make the section go a little bit faster. You'll see that in a minute. All right, so when we're finding an inverse function, we're going to first look at the graph of the inverse function. So right here, we have the graph, or a portion of the graph at least, of our basic sine function that we practice graphing. So it starts at 0, 0, goes up to pi over 2, so on and so forth. Now, we talked about last semester in college algebra for a function to be invertible, or have an inverse, that it has to pass the horizontal line test. And if you imagine taking a horizontal line and drawing it across this graph, the sine function would not pass the horizontal line test. So what we do is we restrict the domain. So we're only going to use this portion of the graph between negative pi over 2 and pi over 2. And then if I use that portion, you can see no matter where I draw a horizontal line, I would only touch one part of the graph at a time, so it would pass my horizontal line test. So the domain we're restricting sine to is negative pi over 2 to pi over 2 when we find an inverse. And the same goes for cosine. Here's a picture of cosine. Wouldn't pass the horizontal line test. So for cosine, we want to make sure we're including all of the possible values on our cosine graph, everything between -1 and +1. If I just use negative pi over 2 to pi over 2, like we did with the sine graph, I would only have positive values of cosine, not positives and negatives. So we have to adjust where we restrict it at, and cosine is going to be restricted between 0 and pi. I know I'm going through this fast, but there's going to be a summary page in a minute you guys can write down. And here's a picture of tangent. We're going to, again, for tangent, just like sine, use the values between negative pi over 2 and pi over 2. If I look at that one period of tangent, this is the one that we used for our key points, it would pass the horizontal line test and therefore be invertible. All right, this is what you guys need to write down, and you can pause it in a minute to make sure you have all of this written in your notes, but this is probably the most important slide out of the whole lesson that you need to know for inverse trig functions. You need to know what values they are defined for. So when we're doing inverse functions, you can see these are all our trig functions, but we've got that little inverse symbol we've used before. We used that last semester, that little -1 power. Remember, that doesn't mean a reciprocal. It means we're finding the inverse. We also know where our functions are defined for. So like sine, we said that was between negative pi over 2 and pi over 2. Well, if we think about what quadrants that refers to in our unit circle, that's quadrant 1 and 2. Or inverse cosine was between 0 and pi is where we restricted the cosine function. So that in our unit circle would be quadrant 1 and 2, so on and so forth. So what you need to get in your notebook is our inverse functions, the name of our functions, what quadrants they are restricted to, and that's because of the restricted domain to make the function invertible. Notice everything is restricted to quadrant 1 and one other quadrant, either 4 or 2. We will have no inverse functions defined for quadrant 3. And then because of the angles we're using, if something is defined in quadrant 4, like our sine function, we don't have a positive angle, we actually have a negative angle there, something between negative pi over 2 and 0. So little note to self here to the side you want to write down, if you have an angle in quadrant 4, it's not going to be a positive angle, it's instead going to be a negative angle, something between negative pi over 2 and 0 is where it's going to be defined if you have an angle in quadrant 4. Okay, so pause the video, get all of this information down in your notes, and then we're going to practice some problems using this information calculating the inverse value of a trig function. Okay, so let's do some problems. So we're finding the exact value of a trig function here, inverse sine of negative rad 3 over 2. Now you'll notice this looks a little bit different than what we were doing when we were evaluating with our unit circle. We saw something before like sine of an angle, and we had to find that value off of our unit circle. An inverse function is the opposite. When we see inverse sine of negative rad 3 over 2, that means sine of some angle y, that's what we're solving for, is equal to negative rad 3 over 2. And our job is to figure out what angle will give us that value, negative rad 3 over 2. Now, if you look on your unit circle, there's going to be two values that actually work between 0 and 360 or between 0 and 2 pi, depending on if you want answers in degrees or radians. And that's where the restricted domain comes in. Because we have an inverse sine function, we know that our domain of sine, and therefore our range of answers that we're going to get out for this problem, falls somewhere between negative pi over 2 and pi over 2, meaning we are looking for an answer either in quadrant 1 or quadrant 4. If there's another answer in quadrant 2 or 3, which there will be, that won't fit within the domain or range of the functions that we're dealing with, so we throw out that answer. So now's where your unit circle comes in handy. So take a look at our unit circle. We're looking for an angle that has a sine of negative rad 3 over 2. And we're restricting ourselves only to quadrants 4 and quadrant 1. So we're looking at that right side of the unit circle. Remember, sine is your y values, and my y values are going to be negative in quadrant 4, so now I know what quadrant I'm looking in. And you can see at the bottom of your unit circle there at 300 degrees or 5 pi over 3, we have a sine of negative rad 3 over 2. So let's go ahead and write that down. So we can say 300 degrees or 5 pi over 3. Now, if our answer is in quadrant 4, like this guy, remember we don't want a positive angle, we want a negative angle, something between negative pi over 2 and 0. So we need to think about what negative angle or what negative rotation would be equivalent to 300. And if you wanted to, all you need to do is you can find a coterminal angle, you can subtract 360, or you can visualize that negative rotation. 300 is going to be in the same position as negative 60 degrees. So that's going to be our answer if it's in degrees. If it's in radians, pi over 3 is equal to 60 degrees. So negative pi over 3 would be the solution. And you want to make sure at the end that that answer you're getting falls in that range of values that we have for the function between negative pi over 2 and pi over 2 for radians anyway, and negative pi over 3 is within that range. Okay, so let's practice another one. We're just going to practice a bunch of these. Arc sine of negative 1, that is the same as inverse sine of negative 1. They're going to flip back and forth between these notations. So that means the sine of some angle y is equal to negative 1. And again, we are looking in quadrant 1 or 4 if it's an inverse sine function. So to our unit circle, on the right side of our unit circle, we're looking for where we have a sine, a y coordinate, and that is at 3 pi over 2 or 270. Because again, it's in quadrant 4, we want to make sure we give that negative angle. So in degrees, my answer would be negative 90. In radians, my answer would be negative pi over 2. Okay, my next one, inverse sine of 3. That means sine of some angle y is equal to 3. Now, if you take a look at your unit circle, you're going to see there's no y values that are equal to 3. So then the next thing we want to think about, that doesn't mean it's impossible, we want to think about, does that work on our sine function? So let's think about what our sine function looks like. It starts at 0, goes up to 1, 0, negative 1, back to 0. The highest a sine function reaches is 1, and the lowest a sine function reaches is negative 1. So my sine function is never going to get up to 3. There's no angle that will give me that value. So my answer here is no solution. Now, we'll talk about in a little bit, if you have an answer like, oh, I don't know, 0.37, that would be a value that we can find a sign for. It's not something that's on our unit circle though, so we'll be using our calculator in a little bit for a problem like that. So it is undefined if it's outside of the range of your original function. So for sine and cosine, for example, anything between -1 and +1 works. Anything outside of those values, you're going to get no solution. Okay, so some more practice. Now we're going to do, the next couple are some inverse cosine problems. Inverse cosine is defined for quadrants 1 and 2. So that means when we're looking for our answers on our unit circle, we're only going to look at the top half of our unit circle. Cosine of y is rad 2 over 2. All right, and cosine is our x-coordinates on our unit circle. Let's look at the top half. We're looking for an x-coordinate that is rad 2 over 2, and that's at pi over 4 or 45 degrees. We're in quadrant 1, so there's no need to adjust our answers. That's it, pi over 4 or 45 degrees. Inverse cosine of -1/2. That means cosine of some angle y is -1/2. Again, to our unit circle, we're looking for where we have an x-coordinate of -1/2. My answer, you can see, is at 2 pi over 3 or 120 degrees. That answer is not in quadrant 4, so there's no need to adjust. Final answer, 2 pi over 3 or 120 degrees. And then we have some tangent problems. Arc tangent of 0. That means tangent of some angle y is equal to 0. Our tangent functions are defined in quadrants 4 and quadrant 1. So now again, we're looking at the right side of our unit circle, and we're looking for a tangent of 0. So actually, before I get to my unit circle, let's think about how we calculate a tangent. To calculate a tangent, we do y over x. So we're figuring out, how can I do a y divided by an x and get a 0? Well, the only way that I can divide two things and get 0 is if my numerator equals 0. So that's really what we're looking for. Where is our y coordinate equal to 0, either in quadrant 1 or quadrant 4? So back to that unit circle, where do I have a y coordinate of 0? And that happens at 0. If I do y divided by x, I would have 0 divided by 1, and that gives me 0. So my answer is either 0 radians or 0 degrees. Next, we have inverse tangent of rad 3 over 3. So that means tangent of some angle y is rad 3 over 3. So let's think about how that can happen. I need to do a y divided by an x and get rad 3 over 3. Well, that's going to happen if I have a 1/2 on top. We did a lot of this kind of calculating with our unit circle, and a 3/2 on the bottom, because then my 2's would cancel. I would be left with 1 over rad 3, and then when we rationalize, we'll get that rad 3 over 3. So this is the situation we're looking for on our unit circle. And if you don't see that to start, you could always guess and check with a few coordinates on your unit circle. You can kind of narrow it down. We know it's not going to be any of those 45-degree increments, for example. Okay, so we want to find, where do we have an x of rad 3 over 2 and a y of 1/2. And you can see that that is at 30 degrees or pi over 6. And it's not in quadrant 4, so no need to adjust my answer to get a negative value. 30 degrees or pi over 6 is my solution. Okay, next we have arc secant. Arc secant is defined in the same quadrants as its reciprocal, cosine 1 and 2. So we're looking here for an angle y that has a secant of 2. Well, if something has a secant of 2, it means its cosine, its reciprocal, was 1/2. So that might be a little easier to locate on your unit circle, somewhere in quadrant 1 or 2 where we have a cosine of 1/2, because that will give me a secant of 2. So to my unit circle, looking for a cosine of 1/2, an x-coordinate of 1/2 on the top half of my circle, and that would be at pi over 3 or 60 degrees. It's not in quadrant 4, so no need to adjust my answer. Inverse cotangent is defined in quadrant 1 and 2. So we're looking, where do we have a cotangent of 1, and how do we calculate a cotangent? It's an x divided by a y. Well, how am I going to get an x divided by a y to get 1? Well, it's got to be something divided by itself. So that's what we're looking for on our circle. Where are my x and y coordinates the same? If I divide them in either order, do I get 1? And if I'm in quadrant 1 or 2, that's going to occur at pi over 4 or 45 degrees. I'm in quadrant 1, so no need to adjust my answer to a negative value. Finally, we have inverse cosecant of 2 rad 3 over 3. Inverse cosecant is defined in quadrant 1 or 4. If I have a function whose cosecant is 2 rad 3 over 3, that is a sine function's reciprocal, and what value we had to take the reciprocal of to get 2 rad 3 over 3, hopefully you know that from all of our unit circle practice, is rad 3 over 2. If you flip rad 3 over 2, you get 2 over rad 3, and then it becomes 2 rad 3 over 3 when you rationalize. So this is what we're looking for. Where in quadrant 1 or 4 do we have a sine, a y coordinate, of rad 3 over 2. So now we're on the right side of our unit circle. A y coordinate of rad 3 over 2 would be at pi over 3 or 60 degrees. My answer is not in quadrant 4, so no need to adjust my answer to a negative angle. Okay, so now let's look at what happens if we have a value that is not on our unit circle, but it still falls within the domain of the values that we're looking for. You're going to need your graphing calculator for these next two problems. So these problems talk about how to type these values into your calculator, and we're going to be evaluating in radians or degrees, so we're going to kind of flip back and forth with our modes. First of all, if you want to find inverse tangent, inverse sine, inverse cosine, we have buttons for those that we'll see in a minute. If you want to type in inverse secant of a certain value, we don't have a button for that, so we're going to use its reciprocal function cosine. We're going to take the inverse cosine of the reciprocal of the number I have. So you can just do 1 over the number you have, or if it's a fraction, you can flip it. If you want to do an inverse cosecant, it's going to look the same. You're going to type in inverse sine and then 1 over the value that you have, or that means the reciprocal of the value that you have. Now, inverse secant and inverse cosine do not require any extra adjustments in our calculator because secant and cosine, their inverse functions, are defined for the same two quadrants. They're defined in quadrants 1 and 2. Inverse cosecant and inverse sine are defined in the same two quadrants, 1 and 4. So we're never going to get a value for one that isn't defined for the other. But tangent and cotangent are going to cause a problem. Inverse tangent is defined in quadrants 1 and 4. Inverse cotangent is defined in quadrants 1 and 2. So if I have an answer in quadrant 1, I'm fine because that's a value that I can find for both functions. But if I have an answer in quadrant 4, I'm in trouble. So if we have an answer in quadrant 4, if we have an x value that's negative, pretty much is when that's going to happen. What we're going to do is we're going to adjust our tangent like we did with our cosine and secant above. We're going to do 1 over the value of that. But then we're going to add either pi or 180 degrees to our answer, because our answer for calculating a cotangent should be in quadrant 1 or 2, but tangent in the calculator is going to give us an answer in quadrant 4. So how do I get from quadrant 4 to quadrant 2? Well, that's a half a rotation around my circle. So to adjust for that, rotate a half away around. That would be either by adding pi, that's a half rotation in radians, or 180 degrees if you're in degrees. So this is only going to happen if you're doing an inverse cotangent that's negative. So this is a one special case that's not going to work in our calculator very well. All right, so let's practice with our calculator. You can kind of see what this looks like. So the first two problems we're going to do on the left side, we're going to do these ones in radians. It says what we want our answer for. So the first thing you need to do is hit mode and make sure radian is highlighted. So I'm going to do that first, and then second quit to go back to my home screen. All right, inverse sine of 0.75, 0.75 or 3/4, that's not on my unit circle, so we use the calculator to evaluate it. So we're going to hit second sine. You can see the inverse signs right above my sine button, and then you can just type in 0.75, and that's going to be our answer to the nearest, let's say, thousandth, 0.848. And remember, that's radians. Okay. Let's do inverse cotangent of 2.3. Now we don't have an inverse cotangent button, so how we type this in is inverse tangent, and then we use the reciprocal of the value that we have. Now 2.3, the reciprocal of that's not a fraction, so the easiest way to get its reciprocal is just do 1 over 2.3, and that is our answer, 0.410 if I round to 3 decimal places. Now that is a radian in quadrant 1. So that falls within the values that I have defined for inverse cotangent, so there's no need to adjust. Remember, only if we get an answer in quadrant 4 are we going to have a little bit of trouble, and we're going to see that in the next set of problems here. Okay. Let's look at the next one. We want degrees, so we're going to hit mode, and we're going to change to degree. Quit to go back to my home screen. I want to do the inverse cosecant of 3.5. Inverse cosecant is not a button in my calculator. We're going to use its reciprocal function sine. So I'm going to hit second sine. And when I use a reciprocal function, I'm going to use the reciprocal of the value I have. The reciprocal of 3.5 is 1 over 3.5. And I get 16.6. Remember, this is in degrees, so 1 decimal place would probably be fine for that. So I get an answer in quadrant 1. Okay, now my inverse cotangent. Second tangent, inverse function. The reciprocal of the value I have, 1 over negative 3.4. And we get an answer of negative 16.4 degrees. And this is where we know we run into trouble. This is an answer in quadrant 4, but inverse cotangent is only defined in quadrant 1 or 2. So the answer that we get is invalid. It's outside of the range of the function that we're evaluating. So again, this is the only special case when you're doing the inverse cotangent of a negative number is where this is going to happen. So once you get your answer, you just have one extra step for this special case to take us out of quadrant 4 and put us in quadrant 2. You're either going to add 180 degrees if you're in degrees, which we are, or you'll add pi if you're in radians. So plus 180 gives me 163.6 degrees. So put a little asterisk by that one. That's our special case. Inverse cotangent of a negative number is the only one we're going to run into a little bit of trouble with the calculator. Okay, the next few problems talk about composing inverse functions, and we did composing back in chapter 2 last semester. We work from the inside out. So inverse sine of pi over 4 is where I'm going to start this first problem. Sine of pi over 4, that's not an inverse function. This is a basic unit circle question. So we're going to pull up that unit circle one more time. I'm going to find the sine of pi over 4. So I find pi over 4, y coordinate we know is rad 2 over 2. So the inside of that function evaluates to rad 2 over 2. Now it becomes an inverse function. Inverse sine of rad 2 over 2 means sine of some angle, I'm going to call it theta, is rad 2 over 2. And remember, we need to consider what quadrants we could possibly get answers for when we do an inverse sine. Inverse sine is defined in quadrant 1 and 4. Well, if my sine is positive, I've got to be in quadrant 1. So now let's look at our unit circle to see if we can figure out where that's happening at. In quadrant 1, where do I have a sine of rad 2 over 2? And my answer is pi over 4. So that is the final answer to this. And notice I started with radians, so I'm going to end my answer with radians as well. We're going to stay with that same format throughout. So this one, you can see that that inverse sine and sine pretty much canceled each other out. So let's try another one. Inverse cosine of 5 pi over 4, or sorry, cosine. It's not an inverse yet. Cosine of 5 pi over 4. So looking at our unit circle, 5 pi over 4, cosine we know is our x value, negative rad 2 over 2. So that inside there becomes negative rad 2 over 2. So now we need to figure out for what angle do we have a cosine that gives us negative rad 2 over 2. But remember, cosine, inverse cosine, is only defined in quadrants 1 and 2. So I will not this time get 5 pi over 4 as an answer because that's in quadrant 3. So to our unit circle, we're looking for where in quadrant 1 or 2 do we have a cosine, an x coordinate of, what was the value I was looking for? Negative, just lost my train of thought, rad 2 over 2. There we go. And that's going to happen at 3 pi over 4 if I'm sticking with radians there. 3 pi over 4. So you can see here my inverse cosine and my cosine didn't cancel each other out. I actually got a different angle as a solution. Okay. Last but not least, tangent of inverse tangent of negative rad 3. So this time when I start from the inside out, I have an inverse tangent first. Inverse tangent is defined in quadrants 1 or 4. My tangent's a negative value, so it's got to be in quadrant 4 where I'm looking. To your unit circle, if I'm in quadrant 4 and I'm looking for a negative rad 3, is the value that we're trying to find, I know it's not going to be at 7 pi over 4. That's my rad 2 over 2. So I've pretty much got it narrowed down to it's either going to be at 5 pi over 3 or 11 pi over 6. And you could do a little guess and check between the two if you wanted to. Now, remember, tangent is y divided by x. And your answer is going to be here at this 5 pi over 3. At 5 pi over 3, if I do y divided by x, I will have negative rad 3 over 2 divided by 1/2. When the 2's cancel, I'll be left with negative rad 3. So my answer there is 5 pi over 3. And because that's not our final answer, well, actually, let's go ahead and adjust it now. If it happens at 5 pi over 3, remember we want the negative angle that's the equivalent because it's in quadrant 4. It's not going to be our final answer anyway, was what I was about to say, but let's just go ahead and be formal with it. Negative pi over 3 is what the inside evaluates to. So tangent of negative pi over 3 is now what we're evaluating. Now you can, because it's a negative angle, use the coterminal angle here if you want. We know that both of those, negative pi over 3 and 5 pi over 3, are in the same location in our unit circle. And if I do the tangent there, we end up with that situation I mentioned a minute ago. You do y divided by x, you have negative rad 3 over 2 divided by 1/2, and you end up with negative rad 3. So you can see in this problem, the tangent and the inverse tangent again canceled each other out. What I started with is what I ended up with. So there is a rule that can help you here. Sometimes when we have a trig function and its inverse, they will cancel each other out, and sometimes they won't. They will always cancel each other out when the inverse function is on the inside. So like that last problem we did for tangent. The inverse function was on the innermost parentheses. In that case, they will always cancel each other out, and whatever value x you start with, you will end with. The only times it is sometimes true is when your inverse function is on the outside, like these two that we did with sine and cosine. Now, the reason the sine and inverse sine canceled each other out is because that angle that we were dealing with, pi over 4, that we started with, was in the place where inverse function for sine was defined. It was in quadrant 1. The reason this inverse cosine and cosine didn't cancel each other out was because 5 pi over 4 is not where inverse cosine is defined at. It's in quadrant 3, and inverse cosine is only defined in 1 or 2. Now, if you don't want to remember the sometimes rule, you can just do exactly what we did in these problems. You can just work from the inside out. You can simplify the inside, and then maybe you'll get back to what you started with, Maybe you won't, depending on where your angle is located, if it's in one of those quadrants where your function is defined or not. But I do think that it's helpful to remember that first bit, when they always cancel. If your inverse function's on the inside, they always cancel. You're left with what you started with, and you can definitely save yourself some time with that rule. But when in doubt, do exactly how we did these problems at the top. Just evaluate from the inside out using your unit circle. Okay, so now let's talk about what happens if I've got a composition problem, but I don't have the same function. You can see here it's a tangent and a sine, and I also don't have something that's on my unit circle, negative 1/3. So what we're going to do, we're still going to work from the inside out. If I have inverse sine of negative 1/3, that means sine of some angle is negative 1/3. And inverse sine, we know, is in quadrant 1 or in quadrant 4. Well, if my sine is negative, I've got to be in quadrant 4. And something that we did earlier in the chapter, if I know a quadrant, I can draw a picture. So what we're going to do is we're going to revert back to what we did before. We're going to pick a point in quadrant 4. We're going to connect it to the x-axis, make a right angle. We're going to connect it to the origin. That's going to be our reference angle for theta. And I know the sine is negative 1/3. So that's opposite over hypotenuse. One of those is negative. It makes sense for the one to be negative. To get the third side of your triangle, Pythagorean theorem, let's call that third side x. X squared plus negative 1 squared equals 3 squared. So I get x squared plus 1 equals 9. X squared equals 8. And then x equals rad 8, or when I break that radical down, it breaks down to 4 and 2, so 2 rad 2. If you can draw the triangle for your inverse function, we can figure out what quadrant's in, we can draw the picture, label our sides. We now know everything we need to know about theta. Think of that innermost parentheses. The answer to it is theta. So now all I have to do is find the tangent of theta. To do this problem, we don't actually have to know what theta is. We just have to be able to get the reference angle for it, which we have. We drew that picture. And if I want to find tangent, if we have a triangle, it's opposite over adjacent. So in this problem, that would be negative 1 over 2 rad 2, which if I rationalize, multiply the top by rad 2, I get negative rad 2. If I multiply the bottom by rad 2 times rad 2 would give me 2, times another 2 would give me 4. Now you can check this one with your calculator if you want to. To check with your calculator, the calculator is not going to give you an exact answer, but you can check the decimal if you want. Type in tangent, inverse sine, negative 1/3, and we get this decimal. Let's make sure that our radical matches that decimal. We had negative rad 2, and get out of that radical, there we go, over 4, and you can see that we get the exact same value. So if you guys are doing this on your homework and you want to check your answers, you absolutely can, okay? But we only need to do this triangle method if it's something that's not on our unit circle, like that negative 1/3, something that we can't evaluate with our exact values that we know. Okay, let's try another one. We've got y equals cotangent of inverse sine of 3x over 5. All right, so that inverse sine in the middle, we're going to think of that like a theta. The answer to that is an angle that we're trying to find. Inverse sine is defined in 1 or 4, and they're actually going to give us a little hint here. They're saying x is a positive number. It's between 0 and 5/3. Well, if x is a positive number, then 3x over 5 is also positive. So my sine is positive, which means I must be in quadrant 1. That helps me draw my picture. Right triangle in quadrant 1, right angle on the x-axis, theta near the origin. Let's label our sides. Sine again is opposite over hypotenuse. Opposite here is 3x. Hypotenuse is 5. We're going to use the Pythagorean theorem to find my third side. So I'll call that third side a y, I guess. Y squared plus 3x squared equals 5 squared. So 3x squared, if I square both pieces in there, I get 9x squared. 5 squared we know is 25. Solve for y, subtract 9x squared. And then we're going to take the square root. Now technically this could be a positive or negative, but we know we're in quadrant 1, so we know my y will be a positive value. So we don't have to worry about that plus or minus. And that's not very pretty, but that's all we know for now about the third side of our triangle. So now let's go back to what we need to evaluate. The inside of that parentheses is essentially theta that we drew our picture for. So our job now is to find the cotangent of theta. Cotangent, well, tangent's opposite over adjacent. So here we need adjacent, which was this guy, over opposite. And that's your final answer. Notice in the instructions it says write an algebraic expression. That's a clue that you're not going to get a nice, pretty numerical answer for this one. And because of that, this, again, isn't something you're going to be able to check in your calculator like the last problem. But same steps as that previous problem. Figure out what quadrant you're located in. Draw the picture, label the sides for the angle and the function that you're given. And from there, you can then find any function you need to given that picture. All right, our last problem of this lesson is actually something that probably is going to look familiar to you from Algebra 2. So this is just right triangle trig. It's allowing us to solve for an angle in a right triangle now using our inverse functions. This is going to be a calculator problem. So here it says a security camera is to be installed 20 feet away from the center of a jewelry counter. The counter is 30 feet long. What angle to the nearest degree should the camera rotate through so that it scans the entire counter? So they drew a picture here for you. We've got a counter that's 30 feet long. The camera is right in the middle. So we're assuming because it's in the middle, our counter is split into two equal pieces, 15 and 15. And because that line is perpendicular, we're going to make a right angle. So we actually have two right triangles that are exactly the same here. So what I'm going to do is I'm just going to kind of redraw the one that you see on the right side. We've got our right angle. We know this side is 15, and we know the camera, here's the camera down here, is 20 feet away. And theta, what we're solving for is the full angle that the camera rotates. That would be through both triangles. So we're going to first solve for the angle in one triangle. It's not theta, it's actually going to be half of theta, so I'll just give it another name. I'll call it alpha. You can call it really whatever you want there. All right, so now we need to figure out how is alpha related to our sides. Well, 15 is an opposite side, 20 is an adjacent side. If I have opposite and adjacent, we know that's tangent. Tangent, our angle goes next to it, opposite over adjacent. And now, if we want to cancel out a tangent, we know what can do that is an inverse tangent. And for our purposes, everything we're going to do is in quadrant 1, so we don't have to worry about any values not working here when we do these in our calculator. So what we need to do is the inverse tangent of 15/20. And your calculator needs to be in degree mode. We are still in degree mode from earlier. So I'm going to hit second tangent 15 over 20. And I get, I'll give it one decimal place, 36.9 degrees. Now remember, that's only half of where my camera is rotating through, but these were congruent triangles. So to get theta, all we need to do is double my angle, multiply it by 2, 36.9 times 2 gives me about 73.7, 73.8, depending on how you round it. I'll use the 73.7 because I didn't round that in my calculator, would be my answer to the nearest tenth. Okay, and that will wrap up section 5-6. It also wraps up our chapter 5. So tomorrow when you come to class, we will have a Math XL workday. Your 5-6 Math XL is going to be due on Tuesday night. But again, tomorrow in class is a Math XL workday, so you'll be able to work on that and ask questions on any part of this lesson that you had. Then on Wednesday, we're going to review for the first part of your test. The first part of your test will be Thursday. Thursday will be a no calculator part of the test. On Friday, we will review one more time for part 2, and Monday next week will be the second part of your test, which will be a basic calculator part. And then just another reminder, you guys have a circuit training that's available to you. It is worth 2 tickets. It's essentially an extra test review for you. It covers everything we've got in Chapter 5, and that is due on Valentine's Day, the 14th. All right, I will see you guys tomorrow. Whatever time left you have in the period now, you can go ahead and start working on your Math XL. Thanks, guys.